Well, I was going to introduce you first.
Okay.
And saying welcome to the first of 3 exciting talks about OpenGL. This one is about Qt versus OpenGL embedded, and is held by Thomas Senyk. And please welcome him.
Thanks. Welcome. I hope you enjoyed your lunch and the presentations this morning. I did. Welcome to my talk about Qt versus OpenGL embedded. I'm not very happy with the topic. It's one of those Monday morning ideas you find brilliant Monday morning and you find awful Tuesday evening. It's not about versus. It's about providing a picture what OpenGL embedded segment means for Qt, what are the different aspects of embedded with OpenGL and Qt. This is a beginner's talk. It's about clearing the picture, but more about that in a second. Let me start introducing myself. My name is Thomas Senyk, graduated computer science in 2009, a small university in the southern parts of Germany. Right after that, I became a professional service engineer with Nokia in the professional service team from 2009 to mid-2012. My job there was helping Qt customers, so mainly outside of Nokia, to succeed with their Qt projects, mainly in the embedded segment, so various industries from home entertainment, automotive, medical, and many more. So I helped clarifying the picture about Qt, how to use Qt, gave trainings, and mainly engaged in integrating Qt and optimizing Qt for certain platforms, for certain embedded chips and so on. That's the reason I'm talking about OpenGL embedded today, because the last couple of years OpenGL became a major aspect of embedded. Every handheld nowadays has OpenGL. Everything from mid to high range chips in embedded segment has OpenGL. Only the very low level chips haven't gotten OpenGL yet, but the price range is lowering there, and more even low end chips will become OpenGL. And a lot of people understand a part of the aspect. They understand what OpenGL is, or they understand the API. They understand they want hardware acceleration. They want 60 frames per second, but they don't. A lot of people don't really get the whole picture and how everything comes together. And this is often a source of problems, a source of introducing things into a project which are not necessary. So today I will try to introduce you and give you the initial picture and the high-level picture of how this should look like and what the different parts are, what they're good for, where they come from, how they should look like. Since mid-2012, I'm at Pelagicor. I'm basically doing the same thing again, helping customers, optimizing Qt, making the right decisions. Now we are focusing on automotive, but besides that, it's a very similar job. On my spare time, it's getting less and less. Going out, I'm Bavarian, so beer. Traveling, job comes in handy, and as any good nerd, I like video games. This is the outline. A little bit about the material itself. It's part of a bigger training about OpenGL. The training contains much more. It's a 2-day training with more complete picture, more details, most importantly, exercises. I've left out basically 2 aspects of that training to shrink it down to 1 hour, and that's all the OpenGL API and the actual usage of OpenGL, and that's the exercises. So we start with a very short glossary. There isn't much left, actually, it's just 2 slides. Then the big topic, OpenGL embedded, the actual real topic here. Implementation of OpenGL, the platform integration. We will concentrate on EGL. There's more than just EGL, but they are all put into appendix If we don't come to that, I'm not sure how long I have at the end. If you don't come to the appendix, shortening it, avoid X11 on embedded. That's basically the appendix. And yeah, the third aspect, OpenGL embedded is windowing systems. I will give a brief overview of the current state of the different windowing systems and, more importantly, their relationship with Qt and how Qt works on them. So a little bit about perspective and scope. I'm only using OpenGL ES2 for my work to date. It might become 3 soon. I haven't had to use Qt4 for a while now. I'm mainly on Qt5. I think that's a good thing. A lot of things getting easier with Qt5 for me personally. And for integrating Qt into a platform, it's significantly easier with Qt5 and embedded Linux. And there are endless amount of defining embedded. I think for this topic, the simplest way to define it is without X11. The scope is much more than that. It's basically any OpenGL version, which is more than OpenGL ES2, and with and without Qt. A lot of the aspects I'm talking about have very little to do with Qt, or have very little dependency on Qt. But Qt has dependencies on those, so it can be worked with and without Qt. Out of scope is any implementation detail. I've had to remove all the API slides to shrink it down to 1 hour. Well, regarding questions, you can interrupt me anytime. I think they need to be recorded, so I guess you have to raise your hand and I will tell you to run. But you can interrupt me anytime. I think answering questions has more value than me holding a monologue. Any questions so far? Haven't talked about much yet. Okay. So glossary, again, it's just 2 slides. The first slide is definition of OpenGL from Wikipedia.org. OpenGL is a cross-language, multi-platform application programming interface for rendering 2D and 3D computer graphics. Let's just dissect that sentence a little bit. It's cross-language. Not everybody's aware of the fact. Most people only use the C API and the C library, or the library and the C API for that. There's binding for, I think, virtually any language, or you can at least use it in virtually any language. It's multi-platform. That most people are aware of that. You have it basically on every platform out there, from Windows, Linux, Mac. Mac has the best support for OpenGL traditionally, to embedded Linux, QNX, VxWorks, and Integrity, and how they all are called. So it's virtually on any operating system out there, at least operating systems which are fit for hardware acceleration. And it's fit for rendering 2D and 3D computer graphics. 2D, that's what Qt is doing. 2D, 2.5D, however you want to define it. It's not painting volumes, but it's painting flat things. That's what Qt is doing as a UI technology. You can do more and you can integrate more. We'll hear about that in the upcoming talk. But Qt is, besides Qt 3D, it's largely 2D. OpenGL context, it's a little bit out of sync here. Wasn't really sure where to put it. It's a very important aspect of my talk because I will use OpenGL context to elaborate a lot of things and to clear things. OpenGL context is a fundamental and basic concept of OpenGL. It's basically an instance of OpenGL. It holds all the state. OpenGL is a state machine traditionally. It holds the state machine. It holds the frame buffer to render to, the surface where your OpenGL paintings will end up in. So think as OpenGL, think as the context as an object holding all of OpenGL, one instance of OpenGL. Common phrase is making a context current. For me at the beginning it was hard to understand what that means. I wasn't really interested in the topic back then. It would be much more easier, a lot of things, if I would have understood it from the beginning. It's loading and activating an OpenGL instance. So you have object which holds OpenGL, which holds an instance of OpenGL, and making that current, loading that, activating that. That's typically phrased at making a context current. And the funny thing about OpenGL is that although this is the very basic fundamental thing to be able to paint, without OpenGL context, you can do nothing with OpenGL. Still, OpenGL has absolutely no API for context. That's a little bit funny, but it actually makes sense because the context can be very platform specific. And so you need a platform integration. The API needs to be platform specific to some degree at least. And as OpenGL is completely and absolutely platform agnostic, there can't be any API for it in OpenGL itself. We will use EGL for that. There's other APIs. There's a context API for Windows and WGL for X and GLX, but we will only talk about EGL right now, today. Any question about the context? It's not necessary that you understand it in complete. Just you have to be aware that it's the fundamental of being able to paint or to do anything with OpenGL. We will talk about that a little bit later. It's one possible platform integration. So it's one possible puzzle piece which completes the puzzle, jigsaw puzzle. And we will see a little bit more about that. But it basically fills all the stuff which couldn't be part of the OpenGL API, because the OpenGL API needs to be completely platform agnostic. But we will talk about that a little bit more in a couple of slides. Any other question? Just shout. Okay, so let's dig into it. OpenGL and embedded. It's about three aspects. They highly overlapping or are a part of each other, but that's how I structured it for this talk. The driver itself is what enables OpenGL to be run. Part of the driver is the platform integration. For this talk, I have put it in a separate separate section. And the windowing system, that's actually part of the platform integration. Again, I put it in the separate section because I think it's important to talk about it a little bit in detail. So let's start with the driver. The driver consists of 2, 3, or 4 things. It definitely and absolutely has to provide the implementation of the API. I told you we have seen in the letter and the definition of OpenGL from Wikipedia that it's an API, and it's OpenGL ES or on any OpenGL version is really just the API. It's an interface. It's a definition of an interface actually. It's not an implementation. It's not a library. There's no real code just out of the blue. It's just the API. And if you get the driver, if you get OpenGL enabled driver, then there needs to be an implementation of this API. On Linux, this is typically called libglfs v2.so. That's one aspect of the driver. The second driver is the platform integration, to be able to run on a specific platform, to be able to run on X11, Windows, Mac, whatever, to be able to get something to the actual screen. You need an integration. And one example is EGL. We will talk about more that in the next section. On Linux, that's typically named libegl.so. That is also, the first two parts are definitely and absolutely part of any driver. They are chip dependent. You can't use the same, or typically you can't use the same driver for different chips. So they are platform specific, they are chip specific. They are really, each version is for very specific use case and for very specific architecture, layout, and platform setup. The other two parts, they often are part of such drivers, but not necessarily. Most drivers in embedded segment have an additional kernel module to integrate the actual driver, the actual access to the hardware. Typically, the OpenGL library will use that module to actually access the hardware. The kernel module is also the one large part of the kernel module is resource management, allocating and deallocating memory, accessing various resources. And some drivers contain additional helper libraries, for example, for compiling shaders, but I don't want to go into details. But just be aware that your driver delivery might be more than just 2 libraries and the kernel module. It might be much, much more. The next natural question is, where do I get my driver? Let's start, not very happy anymore with the order here. Let's start with the chipset vendor version here. That's the usual one. That's the one you should aim for in embedded segment, because that's naturally the best thing you can get, and often it's the only thing you can get for embedded. So your chipset vendor, NVIDIA, Freescale, Qualcomm, or whoever you buy your chips from, whatever is on your board you buy, will have to provide you with an OpenGL driver, either open source or closed, but closed and proprietary is the significantly more likely one. Besides Raspberry Pi and NVIDIA Core, and that's only part open source, there isn't any real open source drivers, excepting a few exotics. It's hopefully highly optimized. That's not always the case. A lot of OpenGL drivers in the embedded segment suck, especially for new hardware, fresh hardware. It very often is the case that they lack features, they have bugs, they are not performing. A little bit more in the windowing system section there. Yeah. And again, it might include kernel changes, kernel module. Very often OEMs maintain their own Linux kernel tree, their own version, their own fork of the Linux kernel tree, Linux source code. You should always ask for examples including source code. They help significantly in integrating stuff. If you got all that, it should be fairly simple to get things running. It's not that complicated actually, as long as the documentation is there. You know how to integrate into your platform and everything. But getting there is often the challenge. Again, because the quality of the drivers often isn't very good. A source of confusion and a source of problems is Mesa. It's also a source of enabling OpenGL on Linux for very long now. It's an open source project. It's way more than it originally was intended for now. Originally, back in the days, 15 years ago or something like that, there weren't any OpenGL drivers for Linux. They were, I think for Mac they had already OpenGL support, and for specific embedded systems like SGI machines, they had very good OpenGL support. OpenGL originally comes from SGI, and they produced hardware coming with that. And people wanted to run their OpenGL programs on Linux as well, but there were no drivers, or just too little, just not for every chip. So Mesa project started, and Mesa originally was a pure and absolute CPU, so software-based implementation, no hardware acceleration at all. It was just for the means to get stuff running, not for performance reasons. It was an enabler, software-based enabler of OpenGL. Nowadays it becomes way more. It actually becomes more than just a library. It's a huge project with various aspects to it. And more OpenGL chips get support for it. Largely desktop chips, largely reverse engineered, but also some OEM-backed drivers, like the Intel drivers in there. It's in the Mesa source code for the new HD graphics cards, not for the old PowerVR ones. But for the new ones, they have open sourced that completely and put that into Mesa. So they are actually the only friendly player in the OpenGL game. It's very unlikely in the embedded segment, except Atom and the upcoming chips, which have the new HD graphics cards. It's very unlikely that you will ever use Mesa in an embedded project, at least to date. Maybe in the future that's becoming better. And Mesa is also a problem or misinterpreted a lot. Once I had a customer, I told them repeatedly that they need to get in contact with their chipset vendor to get proper drivers. For some reason, they didn't get them. Not sure why. They didn't really communicate that to me. But one day they came to me and said, hey, we got OpenGL support. Awesome, but it's horribly slow. Say, okay, what have you done? Yeah, we've compiled Mesa and put it on the board, and now we have like 2 frames per second on a 500 megahertz chip. And I think, yeah, okay, that's not surprising. It's running on the CPU. It's not using anything of your GPU. It just uses the CPU to calculate everything you put in OpenGL. And that's bound to be slow, at least on embedded. On desktop, it becomes usable nowadays, at least, especially with the new Mesa drivers and the new architecture there and everything. But on embedded, it's definitely a no-go, unless you have proper and complete support of your chip in Mesa, which again is unlikely. And the third one, that's kind of a new player there, and it's Microsoft's fault, and it's Google which saves the world. Microsoft tried to kill OpenGL a couple of times, and they have pretty bad support for it on their operating systems. I have a gaming machine home, so I always have OpenGL support, but I heard that actually in reality only half of the Windows machines have OpenGL support at all. I have no numbers to back that up, I just heard that. And that's what Google tells the world why they had to make Angel, or Angle, however it's pronounced. And Angle is kind of a transport layer from OpenGL to DirectX. They actually have a lot in common, and transporting OpenGL commands or translating OpenGL commands to DirectX commands is not that difficult. I mean, in practice it's difficult and it's a huge project, but from a technology perspective and from a high-level architecture perspective, they have so much in common that it's definitely doable, and Google did it. The reason for that is because Google are a strong player behind WebGL. WebGL is OpenGL in your browser, and to have that on every platform, you need OpenGL support on every platform. Windows sucks with OpenGL support. They had to solve that, and that's the way they solved it. Again, nothing for embedded. I just wanted to make the picture complete. Yes?
How does Gallium 3D fit in there?
Gallium 3D is, however you want to see it, either part of Mesa or part of EGLFS or its own project. It's a driver interface which hasn't hit embedded yet. It's a way to... So the OpenGL API in theory doesn't have to be vendor specific. In theory, that could be completely vendor agnostic. The lib for OpenGL could be completely vendor agnostic and could use a standardized interface to access the hardware. And that there's then the block to actually access the hardware could be proprietary. And Gallium tries to achieve that by enabling 2 interfaces to various aspects. To the platform, there's one interface, and to the actual hardware drivers interface, and then there's an interface to the actual OpenGL implementation. But that's solely EGLFS right now. At least I haven't seen it anywhere else yet. But the idea behind it could actually be ported or used in embedded as well. Raspberry Pi project, for example, they've open sourced their OpenGL implementation part, but they have not open sourced their hardware access part and the resource management and all that. And if that interface would be standardized and others would be using this interface, then you could have the same as Gallium for embedded. You could actually use Gallium, I guess, for embedded, but right now it's very specific for X11 and DRI and all that X11 stuff you don't really want to have on embedded. But in theory, it could become the interface between those aspects. Yes?
But I think we shouldn't miss out all these initiatives for getting open source drivers. So we have the Lima project, we have the project for the Qualcomm chips, I forgot the name.
Yep.
And I think they just went to mainline in the 3.12 kernel,
Yep.
and so on. So I think
some of them are reverse engineered. I don't follow each
they are
of every.
all reverse
Yeah.
engineered.
Yeah.
But I think especially the one for the Qualcomm chips seems to be quite usable.
Okay. Also for performance. I mean, that's the problem of reverse engineered drivers typically, that they work, but they have
I've
a huge
seen
problem
some
with performance.
numbers in some specific cases, not in all, but some specific cases they seem to be faster than the
Okay.
original binary blob
Okay.
implementation.
For what Broadcom chip is it? Is it for the video core?
Qualcomm.
Qualcomm is video core, right? Yeah.
And well,
Okay.
yeah. And
Okay.
there's some talks online on the X developer meeting.
Okay. But is
And
that okay? The kernel modules, you mean getting mainline?
well, it consists of kernel modules, and I think it's of kind of Gallium integrated stuff. But I'm not following it closely, but I think it's worth mentioning.
Again, Gallium is relatively X11 specific. I'm not a huge fan of X11 myself. I try to avoid an embedded segment. We will talk about that a couple of slides. I guess it's arguable, but you're right. There are a couple of good initiatives from community trying to reverse engineer GPU drivers. For NVIDIA, for endless years, the Nouveau drivers around. On AMD, you have open source drivers and all that. But they all relatively desktop-centric for a lot of reasons, mainly because most geeks, most people able to reverse engineer that are not interested in embedded that much, at least used to be that way. And for legal reasons, I guess, it's not very often that people actually want to take those. But yes, there are good initiatives. I hope that they just all become together and be friendly to each other and standardize on something like Gallium to actually enable something usable on various platforms and to ease out the problems of OpenGL and embedded. Mm-hmm. Gallium? Okay. Okay. Didn't know that.
I think no one heard you.
Didn't it have a hard dependency on DRI and all that stuff?
No, you can just compile it without any X dependencies.
Okay.
So at least Nouveau and the Radeon drivers work very well with that.
Okay. That's interesting. I thought that they have a hard dependency. At least they used to have a hard dependency on DRI, I think. Maybe not. Maybe I'm having misconceptions here. But again, for embedded, the problem is it's unlikely that you have or there aren't that many chips where you have reverse engineered drivers, and even if you have those, it's not very likely that they are highly performant. Seems Broadcom is one exception there with their video core. So maybe the picture of Mesa isn't as dark as I painted it. Any other questions? Yeah. Platform integration, we already touched that. It's part of the driver. Why do I need that? So OpenGL is completely and absolutely platform agnostic. There's no way of accessing a display, your display server, or your Linux frame buffer, or whatever your display is. There's no way of creating windows. There's no way of creating a surface. Not even for context. We've already talked about that. So there's a lot of puzzle pieces missing in OpenGL API for good reason. The reason is OpenGL API is completely platform agnostic. So you need something between OpenGL and your platform, some interface, some way of getting those two together and filling up the empty spaces to create the window, or get it combined with OpenGL, create surfaces to paint on, create a context. That API needs to be to some degree platform specific. So it's actually typically not, or yeah, let's have that later a little bit. So EGL is one possible thing you can put in between. There is others. I think all others are a wrong decision embedded, but that's an opinion. In appendix, I will talk about DRI, GLX, which is an alternative to EGL. GLX is the alternative. DRI is a puzzle piece to enable it. We will have that in the appendix. For now, we'll want to try to concentrate on EGL to make it simpler. So EGL is the interface between OpenGL and your platform. And that's largely what the definition of Kronos.org. Kronos is the industrial consortium managing and maintaining the OpenGL API, developing it further. And that's the definition. And EGL is one API. Oh, 50 minutes. Okay, I have to be fast now. Yeah. The important aspect here is interface, the fourth word. It's an interface. It's not a wrapper. It's an interface. So actually, you still need to communicate between, enable and implement the communication between EGL and your platform. There's interfaces for that. EGL is that interface for that, but you still have to do it. So there's still a lot of resources you have to actually create with your native platform interfaces, display, the connection to the display, windows. There are three good examples where you have to actually use your native APIs. And then you have to use those and feed those into EGL, map things, like the display is just mapped to another one. So you have a native display, and you use that native display to get an EGL display with EGL get display. This is then used onwards in the EGL API. You create a surface for window. So window is just the handle to take care about all the window management stuff, mouse events, focus, maximizing, and all that stuff is handled by the window. And the actual content of the window is the window surface. And you create that with EGL because it needs to be an OpenGL resource to be able to paint with it using OpenGL. So you use that to EGL, you use EGL create window surface together with your X window, your EGL display config on the next slide. Yeah, and then you create context again using your native display, or your EGL display should actually be there. Sorry. And again config, next slide. And before you paint, you have to prepare your painting, making the context current. We've talked about that. Actually making an instance, activating an instance of OpenGL. You do that on the surface using the context you created and using the display. Very important to understand is, again, EGL is part of your drivers, and the driver is platform specific. So it's chip specific and platform specific, so you typically get a driver. It could be a driver that contains multiple drivers actually, but one of those is for X11, one of those is for Linux frame buffer, one for Wayland. Linux frame buffer and Wayland often share their implementation, or sometimes. But EGL as well as the OpenGL library, they are all not only chipset specific, but also platform window system specific. OpenGL library not necessarily, but sometimes. EGL definitely. EGL config I will skip for now. don't have time for that. Qt in general makes that easier only if you want to integrate Qt on a new system or a new platform. You have to deal with those things. Typically, if you want to use Linux frame buffer or something like that, you have to deal a little bit with that. But in general, Qt on every platform, Qt is already supported. You don't have to deal with that. It's just important that you understand what it's good for, where it comes from, and how Qt will use it. And those are code snippets, a little bit modified to fit them on the screen, but code snippets from Qt code. I have to rush a little bit because I don't have that much time left. So very important, the quality of the platform integration is vital. You can have awesome OpenGL implementation, and the whole OpenGL stack is perfect and awesome and the best OpenGL chip you will ever see. But if the platform integration aspect of that driver is crap, then it doesn't matter, then the whole driver is crap. I had that, for example, on the IMX53 2.5 years ago, or 3 years ago. They had very good Linux frame buffer drivers, and I know that the driver overall had gotten a lot of love, but the X11 version did not. And they had somewhere in the driver, they had a copy, software-based copy, that ruined the complete performance, and it was completely unusable from a performance perspective. So choosing which platform you want to use should be highly so one very important argument is the quality of your OpenGL driver for all the different platforms, all the different windowing systems. Those are 4 windowing systems I know which are used on Linux. Certainly more than that, exotic ones, but those are the major 4 ones, I think. It's no windowing system using Linux frame buffer directly. X11, which is the desktop standard, and for embedded, it's used in some projects. I think it's not a very wise idea to use it in embedded, but it has been used and has been successfully used. So there are a lot of people who will argue that it's actually a good choice for embedded. I'm not a big fan of it, but that's definitely discussable. directfb, I don't know much about the current state. I've seen lately a few videos. It seems to be quite good right now, especially OpenGL support seems to be good, but I have no personal experience for a couple of years now, so couldn't tell. Yeah, and Wayland is the future. The important part about that slide is there's 3 windowing systems. So that's the since Qt 5, there's a thing called QPA, which is the platform abstraction, and this plugin-based platform abstraction. So you have a plugin for each of those platforms. So you can have the same Qt build running on X11, on directfb, Wayland, and so forth, and so forth. And the only thing differing there is the plugin, the platform plugin, and this is a list of Linux platform plugins. And the first 3 are windowing system-based ones. So X11, XCB is an API to access X11. Wayland and directfb, I don't know much about directfb, but it has very good support, I've heard, but I couldn't tell. XCB is probably one getting the most love because X11 with KDE and all the other projects is a vital part of Qt ecosystem. Wayland support is pretty good in Qt 5. I've using it on a couple of platforms. It's not perfect, but it's pretty good. It's definitely usable. The next 3, EGLFS, Minimal, EGL, and KMS, they are non-windowing system plugins, so they don't connect to a windowing system. They just open a display and directly accessing the display. There's various ways to modify them and to adjust them, especially EGLFS has an API to modify them and integrate them to specific platforms. Important about them is they have no multi-surface and definitely no multi-process support. EGLFS has gotten some multi-surface support. Depending how you define multi-surface support, it has it for a long time now, and now it got more of it. But it's not necessarily always working. And first stage and first interaction, you should consider EGLFS to be single surface. And the last one is minimal, and Linux FB, they have no OpenGL support. I think I don't want to go through those slides. No windowing system is a good choice, especially for early stages of your integration and to get early numbers, get things running before the X11 drivers are working or before your Wayland drivers are working and all that. And it can be even a product, it can be a very nice thing to use because not sure if you heard about the Qt Compositor APIs. It's an abstraction of the Wayland server part. There's a QPA plugin, a platform plugin called QWayland, or it's in the QWayland module. And that's the client part. And there's also an API for the server part where you can actually very easily write the compositor. And the no windowing system plugins can be a very good use case for running the server directly on the display. The server doesn't need a windowing system. It is a windowing system. Yeah. Pros and cons, not that important. It's the only thing which might be interesting is that it's by far the smallest footprint and the fastest pipeline. Especially pipeline part is very vital because you don't have additional compositing. So you directly access the display, and that's bound to be faster than having a windowing system. Yeah, and the most advanced no windowing system platform plugin is EGLFS. It was originally coming from Qt4, forward ported. Back then it was called Simple GL, and now it's called EGLFS in Qt5. It's single process, single surface platform plugin. Again, not 100% single surface, but to a large degree. It has supports for many things like mouse cursors. The other no windowing system doesn't necessarily have. I think KMS has it. Minimally Chill does not, I think. And on certain platforms like the Raspberry Pi, it even has support for hardware accelerated mouse cursor, where they use a specific layer, hardware layer, to put the mouse in and use hardware compositing to composite the window with the mouse cursor. It has become quite complex by now. A lot of people in Oslo weren't happy about the state of EGL because Girish put everything in and it got a beast. So they started minimal EGL because EGLFS used to be, or was one idea behind EGLFS was to be a example showing a code example showing how you would what you would need to get EGL running on a OpenGL platform. A minimal example. That's it not anymore. It's a very relatively complex thing by now. And minimal EGL is the code example now. The behavior can be modified on make-spec level with EGLFS hooks. That's one of the things I'm working with a lot. Maintaining the EGLFS hooks for the IMX6. Yeah. So I just show you what EGLFS is. This is the API. It's a class with all virtual functions, and what you can do is in your makespec is a makespec in general is a way to tell Qt how to compile Qt, and a device makespec is specifically for device. So there's device makespec for Linux for IMX6 that has specific compiler flags and linker flags and all that, and also it has a EGLFS hooks implementation. It has a subclass, or it's diverted class from QEGLFS hooks, which re-implements a couple of those, not all of them, but a couple of virtual functions here. And there you can specify specific behavior for specific platform dependent stuff. For example, creating a window, which is necessarily even if you have no windowing system, you still need a window object, which can be the complete display, but still you need a window object. And on the IMX6, you have a proprietary Vivante-based API to actually create one. And so in that makespec, I'm re-implementing that. Show you. So this is the constructor of the hooks plugin. There's a proprietary API to get the display. Sorry, wrong line. This one. To get the display. Now we have a native display. The type of that is EGL native display type. And later on, when you create something, you will feed that back. Oh, actually, this will be returned by this function down there. Maybe I should keep on that screen. The EGLFS plugin, the upstream code, the normal code, will take care to feed that back to EGL. And creating a window is another proprietary API. It's FB create window. It sounds upstream API, but it's actually proprietary. Yeah. There's a destroy window now. I've not put that in there. Not sure how to use that. So yeah, that's a way to, and so what you can do now, or what that enables, is that you compile Qt with specific options, device, and then specifying device, and that then runs out of the box on even proprietary OpenGL implementations or APIs. So if you compile Qt for IMXX out of the box, the EGLFS plugin will run on that properly and efficiently and right with the right APIs and everything. You define that in the QMakeConf of the make spec. Sorry that I had to rush so much. I should have shrinked the presentation a little bit further down. Any questions so far? I think now is probably a good time to ask questions. We are close to the QA. Yeah.
I understand beneath the EGLFS plugin there's also a KMS plugin, and I think they are very similar. Can you tell me what the differences are?
I'm not very experienced with the KMS plugin, largely because I haven't had any KMS enabled boards for a while. I think the last one I had was the Raspberry Pi, and even on the Raspberry Pi, EGLFS support was significantly better, so I've used EGLFS in that. But in general, so first of all, let's start what KMS actually is. KMS stands for kernel mode settings. So kernel mode settings means that it's a kernel-based API to set the mode setting, and mode setting is basically your screen setup. So what color format do you have on your screen, what resolutions do you have, what refresh rates, and all that. That's called mode settings, and kernel mode settings is a kernel-based API to set those. A standardized Linux kernel-based API with a user space library. And the kernel mode settings plugin using that to set the resolution of your screen. I guess it's just getting the resolution actually. I'm not sure if it's actually setting it. I would have, yeah, it could be. Besides that, I think it's not as advanced as EGLFS in a lot of aspects. It probably has no support for, so it has no EGLFS, something like that. If you want to make platform-specific stuff, like enabling hardware layers for your mouse cursor, you have to actually change the code. And you have to have a patch or something for Qt. You cannot really upstream that because there is no interface, no API to actually upstream something like EGLFS in kernel mode settings. That's a huge difference. I would assume it's significantly simpler in a lot of aspects. And I would assume it's supporting significantly less. But I would have to dig into it to actually see it, what it actually supports.
Thank you.
I would like to know if your slides will be available in electronic form.
So my slides are actually a QML presentation. I guess I will get a mail soon to give the slides to KDAP. I'm not sure yet. I will most likely produce a PDF out of that and send that to them. And I might even put it on Gitorious or GitHub or something. I haven't done that yet. But I've done that in the past and I see no reason why not. So I assume that at the end you will have a download link for the PDF and a clone link for the source code. I assume KDAP is planning to put all that into the Qt project homepage after the. I would from the experience from the last years, it's typically after the American conference because you don't want to spoil. Yep.
So one problem that I had with
Can you
with all this one was that when I was trying to compile Qt Wayland, especially the server side, I could never really find out the right combination of Qt core and Qt Wayland server that would work together. Is there a better way to track the development for Qt Wayland?
You mean in relationship with the different platform integrations, Linux frame buffer, and what platform?
I guess EGL.
No, what chip?
Well, we were doing the desktop, I guess.
Okay. So if you have two different libraries, then it can actually be a little bit complicated. I haven't enabled it on any platform with multiple drivers. I can see a big problem there because libwayland has to connect to Qt core, and Qt core has to link to libEGL, or at least libopenGL, and that's typically linked against libEGL, or has at least a dependency on it. So this can actually be a big problem. I can tell you that the problem is solved as soon as you have Linux frame buffer and Wayland frame buffer drivers in the same driver, which is the case for the IMX6, which is awesome because it enables that use case. Worst case, you have to have two Qt versions. One enabling Wayland server and one enabling Wayland client. But that would be pretty dumb, especially with the new QPA architecture. Loading different libraries on runtime could be a solution, because the symbol dependency of Qt towards OpenGL should be fairly platform agnostic. So putting the two versions in two different directories and with LD library paths or something like that, loading different versions at runtime could be a solution. And then you can use one or the other platform plugin, because the platform plugin has platform-specific symbol dependencies. Compiling could be a little bit nasty there, but it should be doable with maybe some hacking. Maybe changing some of the project files in Wayland, Qt Wayland. Might be necessary to not use package config, or to actually use package config and not use it for Qt base or something like that. But so it could be a little bit nasty to get it actually working and running, but it should be possible to do it as long as you make sure to load the right library version at runtime, if you have to. And if you have one, you should be able to enable it very relatively simply. So on the IMX6, there's the Linux frame buffer API, and that's a subset of the Wayland API. So Wayland API, if you enable the Wayland API, you have the Linux frame buffer API as well, from a header perspective and from a symbol perspective. So you just enable both, and you can run EGLFS and Wayland, same libraries, same configuration, everything. You just pick another library, and that's an awesome setup and makes life easy. It's not working upstream right now. Sorry, this is not working right now with the upstream driver. You need a special version with a fix in it, and the fix is not upstream yet. I have to contact my Freescaler contact again to force them to finally upstream that stuff. But it's doable. It's just a little bit more complex than the usual setup. other questions? I have the appendix. GLX, it's basically an alternative to EGL for X11 only. It has a lot of features and a lot of stuff in it. It can be transported over network and such stuff. So it's definitely more and bigger than EGL. It's also huge for that reason. DRI is a part of it, direct rendering interface. It's the one not using the transporting OpenGL calls. That's the architecture picture of DRI. I have not very much experience with DRI, I just know that it's quite complex and not the most efficient way. It's certainly not as efficient and lean as EGL. I tried to stay away from it. It's for desktop OpenGL. It's more complex, it has a bigger footprint, and it's not as efficient as EGL. And even if I have to use X11, I hope to get EGL enabled drivers, because EGL can run on X11 as well. You don't have to use DRI and GLX on X11, you can also use EGL. Interesting and nice part of DRI, or DRM is part of the DRI project, but it's not, it has absolutely no X11 dependency, and it's direct rendering management. It's basically resource management in the kernel. You have to allocate and deallocate memory and all that stuff. And there's a standardized API for that. There's a userland library to be used by the OpenGL library, and that's actually one aspect. It's one aspect of having an interface between your graphics card and your OpenGL implementation, the stuff we've talked about before. And DRM is one aspect. It's not the complete picture, but it's at least one aspect which is actually standardized. It gets picked up too little. It should be picked up more vendors. I hope that will be better in the future. Kernel mode settings we already talked about. Ooh. How many times do I have left? Minutes?
I'm going to say thank you in 2 minutes.
Okay. Then I say thank you now, I guess. You have 2 minutes left for questions. Yes?
So I guess you have two real options when you're doing OpenGL on embedded, and that's either going for the EGLFS plugin or the Wayland or KMS. Maybe you can mention some use cases when you should pick Wayland and when you should use EGLFS.
Yeah, right. I kind of skipped over that in the slides. So EGLFS is always a good start point. To get your graphics card knowing and to know your specific and platform-specific APIs. It's relatively simple. Okay, depends a little bit, but it's a good starting point. It's definitely good for demos. I'm mainly using it for any demo I'm doing, unless I want to showcase Wayland. Then I have to use at least Wayland as well. So EGLFS is single process. If you can live with that, then EGLFS is probably good. Or it's probably a good choice if you actually want single process. Single process in terms of single process UI, not single process as in only one process on your system, but one OpenGL enabled on a specific screen. Then EGLFS is a very good choice because it's lean, it's small, there's no additional compositing and all that stuff. So for performance and stack reasons, EGLFS is a good choice. If you want single process, if you want multi-process, then EGLFS is a no-go. Just not working, just not enabled for that. Then you have to choose something else. And the two choices you have, or the three choices you have on Linux is X11, directfb, and Wayland. X11 is old and fat and ugly. directfb I don't know much about. It's supposed to be lean, small, incredibly fast, and highly customizable. But it has a limited user base and a limited support. But it's a possible choice, definitely. And Wayland, the future. I think it will eventually take over the desktop and embedded and uniform those and be awesome for everybody. It's young. It has its limitations right now. It's especially for the desktop. It's not fit yet, I think. For Wayland, it's fit, I think. I was planning to do products based on Wayland. Unfortunately, it got cancelled. But I think it's ready for embedded. And as soon as you want multiprocess, then my first pick would be Wayland for multiprocess on embedded Linux.
So, thank you to Thomas for enlightening us all with OpenGL and Qt. And we will continue today's program in 15 minutes. So, there's a short break where you can visit the exhibition area or whatever you need.
Thanks.